in whatever class you took, you graphed things that looks like this, okay? These are systems of inequalities, and these in particular are all linear, right? So we needed to match these up. Where did a lot of you start? Like, where did you start looking for matches? Like, is there a particular line that you looked at first? Did you start with this first graph and try to figure it out from there?
I just did the first two equations and I found it in slope-intercept form, and then I looked at the lines and then figured out.
Okay, so Madeline put these in slope-intercept form and then figured out which lines matched and made sure the shading was appropriate, right? So if we change these two equations, right? This is the line y equals x. And this, if we solve for y would equal, is it minus 3x plus 2? Okay, so what does that match with? Which one?
I said
B?
B.
Do we agree with B? Okay, we have this is the line y equals x. Here's a y-intercept of 2, slope of negative 3. Now, do you notice how like one line is solid and one line is dotted? How do we know which line is solid versus dotted?
If the inequality is equal to.
Okay, if we have that equality in our inequality, it's a weird sentence, then it's going to be a solid line. If it's a strict inequality, we have that dotted line. Okay, so those are matching up. Okay. What about this one? Which graph matches this one right here? A? Okay. Some of you are putting these into slope-intercept form. This would be y equals negative 3x plus 2, okay? Which is the same line as over here, right? But what's different about it from A to B? These two are the same line, but this one was dotted versus that one is solid, and we know that from the inequality, okay? And then, do you remember how I taught you the second way to graph last week? Should we review that? Okay. If we change this to an equal sign, if I plug 0 in for x, what's our y-intercept?
Negative 2.
-2. And if I plug a 0 in for y, what is our x-intercept?
4.
Okay, so if we have an x-intercept of 4 and a y-intercept of -3, here's that line right there. All right, what does this third one match with? C, which means this one has to be D. Okay. How do we know where to shade? Like, why are these shaded in only a particular space? Okay, so this is actually an overlap, right? If we were to look at, let's look at specifically, let's look at A right here. Okay. If we pick a point, let's say 0, 0. If we plug 0, 0 into this inequality, does it make sense? Yes or no? Is 0 plus 0 greater than 2? No. So that line, we would have to shade away from 0, 0. Right? If we pick a point, doesn't matter, let's say 0, 0, and we plug it into this second one, 3 times 0 minus 6 times 0. Is that less than or equal to 12? It is, which means 0, 0 satisfies this one inequality, and we would have to shade towards it for that inequality. Well, what is actually shaded on our graph? Where they overlap. Okay? Just kind of coming back. All right, so then I gave you the task of coming up with what this is right here. Okay? What was your strategy? Figure out what the lines would be. That's not so bad, right? So let's just talk about the equations first. Jack, what would this line be right here?
That is
Y equals negative x plus 3. So we have a y-intercept of 3, and we have a slope of negative 1. Okay? Now let's talk about how it's an inequality. Okay? Do we want to shade, so for this line right here, would we want to shade towards or away from 0, 0? We would want to shade towards it, right? Because we have shading right here. Okay? So if we want 0, 0, if we want 0, 0 to satisfy this inequality, do I want my alligator eating the y or not? Towards the y or away from the y? Which one? We're going to get 0 and 3 if we plug in 0, 0. If I want this to be true, which one's bigger?
3.
3. So we would want our inequality to be facing. So that's it? Why no?
Because it's not dotted, so it has to
It's not dotted. Okay. Okay. Now, did somebody rewrite this to look different? Did anybody write x plus y is less than or equal to 3? Or 2x plus 2y is less than or equal to 6? All of those are the same line. There's an infinite number of ways to express this line. So it's okay if you rearranged it. Okay? How many of you rearranged it but you're not sure if you're right or not? Okay. Let's talk about our second one, this dotted one right here. Okay? Reagan, what did you write for this line right here? Just the equation.
y.
Don't worry about the inequality.
Oh.
How about just y equals?
I know, it takes me a second to figure it out. 2x minus 3.
Okay, 2x minus 3. Because we have a y-intercept of 3 and we have a slope of 2. Okay, so now we are shading this way. So if we were to plug in 0, 0, we don't want the inequality to work because we're shading away from that coordinate. So what kind of inequality would we need? Do we need a less than sign or a greater than sign? Less than. If we plug in 0, 0, we want 0 to be less than negative 3 because that is not true. Okay, and some of you may have written this as, a number of different things. Did anybody rearrange this for fun? Or start starting things off? You did? What?
We have y minus 2x is, would have to be less than 3.
Well, you would almost have to have 2x minus y is greater than 3 if you wanted to rearrange it. Like that. Yeah, that would be fine. Okay. All right, now, I'm going to come back to this. And you don't necessarily have to write this down, but when we have a system of inequalities, we are going to get a shaded region, and it could look like a number of different things. Okay, there's 3 options for what we have. You could have a bounded region to where your shading is within a contained area. Or you could have like what we just saw, where your shading is unbounded. It keeps going. All 5 of the graphs on your blue sheet are unbounded. They keep going. Okay? It's also possible that your shading won't overlap at all and nothing would be in common, and so there's no solution. Okay? If I would have changed the inequality signs on that D graph, if the shadings were going away from each other instead of towards each other, that could have been a no solution. Okay? What's going to be important though, do you see these coordinates right here? We call these vertex points, and you're going to actually need to find them. Okay? One vertex, plural, vertices. Okay? Vertices are the points of intersection that are bounding your shaded area. Okay? And we will have to figure out what those are. Okay. Notice how this is a point of intersection right here. That doesn't matter because it's not with the shading. These four coordinates right here are all with the shading, so those are the ones that matter. So you have 5 graphs on your blue sheet. Which one doesn't have any vertices at all? Graph D. There's no intersection. There's not going to be any vertices. The other 4. How many vertices are there? 1. Let's go back to here. Whoops. Let's go back to here. Okay. Since there's only one of them, it's a vertex. Okay. Otherwise, plural, we would say vertices. What is the coordinate of the vertex?
2.
Okay, so it looks like it could be 2, 1. How can we be sure that that is actually the correct coordinate?
We plug in their values in for X and Y.
Okay, but we would have to make sure we're talking about the equation. So this is where 2 lines intersect. Well, how do we find where 2 lines intersect? We saw the system of equations, right? So if we look at the equation, y equals x plus 3, and if we look at the equation, y equals 2x minus 3, if the coordinate's 2, 1, does 1 equal 2 plus 3? I said that extremely backwards. This is negative x, that's why. Whew. Okay. Does 1 equal negative 2x? Negative 2 plus 3. That works. Does 1 equal 2 times 2 minus 3? Okay. If we guessed a coordinate and it didn't work, what are you going to have to do? Substitution or elimination and do the algebra to find it. Okay? It's fine for you to look at the graph to get a coordinate, but if it doesn't work in your equations, you got to do algebra. Okay. So we're going to do one example that's a little different from the rest. X squared plus y squared is less than or equal to 25. What is that?
It's a parabola.
It is not a parabola. A parabola only has one squared term. This has 2 squared terms. Let's just think of the equation. X squared plus y squared equals 25. What does that look like? If there's a mountain. A circle with radius 5. X squared plus plus y squared equals r squared is a circle centered at the origin. That is a terrible circle. I'm going to go ahead and fix it. Whew. Okay, so I graphed the equation. I made it an equal sign and I graphed the equation. Okay, how do I figure out where to shade?
Your inequality.
Okay, let's pick a point. What would be a fun point to pick?
0,
0,
0.
0 sounds great. If we plug in 0, 0, does it satisfy our inequality? 0 squared plus 0 squared is less than or equal to 25. So very lightly, shade in inside. Okay, this isn't your final answer. This would just be very, very lightly. Okay. Or not at all if you want to just keep track, but I'm going to help you out a little bit here. Okay. Now, x plus 2y is less than 5. There are two different ways you can graph this line, but we need to graph the line x plus 2y equals 5. If you would like to put it in slope-intercept form, you go for it. Or you can use the intercept method, like we did before. If I plug 0 in for y, what is our x-intercept?
5.
Ooh, that's a nice one to pick then. Okay. If I plug 0 in for x, what's our y-intercept?
5 back.
There. It has to be a dotted line because of the strict inequality. Okay. Now, especially since you're not graphing on graph paper, this might be, well, some of you are, some of you aren't. Our vertices may be a little bit more difficult. Let's talk about where we would shade. Would we, if we plug in 0, 0 to the inequality, would we shade towards or away from 0, 0? 0 plus 2 times 0, is it less than 5?
Yes.
That works. So we want 0, 0. Okay, so we would shade towards it. All right, do you see why I did this? Where do these overlap? Where mine is turning
Blue.
bright blue, right? So if you shaded lightly, make sure that you go back in and you shade really dark all of the coordinates that represent your solutions. Okay, so where I am shading in black, this is where all of the coordinates are satisfying our system. Okay, how many vertices do we have? We have 2 vertices. We have one right here, and we have one right here. Okay, those are the 2 intersection points that are with my bounded region. Kaden, do you have a question?
So if the inequality is true, then
That's where you want to shade.
you shade towards the 0.
Right, so if you plug in a point and it works, you would shade towards that point. If you plug in a point and it doesn't work, you shade away from it because you don't want to color it. Okay, so these are the points that satisfy both. Okay, and then our corner points, our vertices are going to be important. Okay, I have no problem with you using the graph to identify them, but they have to be accurate. If you have a coordinate that's 1/2, 3/2, you might not get that without algebra. Okay, so don't be afraid to use the algebra. All right, now, when we're talking about our vertices, we are looking for where the equations x squared plus y squared equals 25 intersects x plus 2y equals 5. Okay? So, I don't know. This one looks pretty nice. What does that one look like?
5, 0.
I mean, we graphed 5, 0 on both of them, right? Well, let's make sure. 5 squared plus 0 squared equals 25. 5 plus 2 times 0 equals 5. Okay? So we know that one of our vertex points is at 5, 0. Okay? Now we need to figure out what the other one is. This guy right here.
Negative 3, 4.
Negative 3, 4. Okay. Well, what's negative 3 squared plus 4 squared? 9 plus 16 is 25. Negative 3 plus 2 times 4, so that's negative 3 plus 8 equals 5. That does work. Okay? Now, maybe your graph is really crummy because your circle was not perfect. Could it happen? It could happen. Okay? How would we do the algebra if you couldn't tell from your graph what it was? Okay? Well, you could use substitution, right? You could say, all right, well, I know that x equals 5 minus 2y, and so then x squared plus y squared equals 25. Okay, and now you have a quadratic to solve. Y. I'm going to get rid of that right there. There we go. Okay. If we wanted to do the algebra here, we would have 25 minus 20y plus 4y squared for this. If I FOIL that out, we get this. Plus y squared equals 25. Okay. Ooh, what happens? Wouldn't these 25s cancel out? Okay, and we have 5y squared minus 20y equals 0. Yeah.
Where did you get the 25 from?
If I FOIL this out from the O and the I in our FOIL, because we have 5 minus 2y times 5 minus 2y. So we take 5 times negative 2y twice. Okay. Okay, so if we factor out that 5y, we get 0, y is 0 and 4, okay, which is what we have for our y values in our algebra. Okay. I can't stress enough, if you're going to use your graph to determine your vertices, you have to make sure that they work in the equation. Change it to equal sign and test them, okay? Because they might not be, like, all of our intersections have been really nice today, haven't they? But they could be fractions. Have you had intersections that are fractions? Yeah. Okay. All right, so tomorrow we are going to take a quiz. We will spend probably the first 15 to 20 minutes of class going over some problems, and then we're going to take the quiz. That's really it. If you're not going to be here tomorrow for student council, then I need to see you, or for anything else.